All right, so what we're going to talk about is graphing linear inequalities. Okay, so the goal is to eventually graph a system of linear inequalities, but we're going to go ahead and start today with just reviewing how to graph single inequalities. So let's go ahead and start right away with an example. The other thing is we're going to do the best we can to just kind of sketch these out, even though we don't have graph paper. But a lot of times when you do these on your homework, you'll have a grid or you'll have a piece of graph paper. All right, so step one. First thing we need to do is we need to write in slope-intercept form. So let's go ahead and let's solve this equation for y. Okay, so x minus 4y is greater than 8. Let's begin by subtracting x from both sides. Negative 4y is greater than negative x plus 8. Now, I'm going to divide by negative 4, and I purposely picked this example so that we could remember what happens when we divide by a negative 4. You're exactly right. We need to flip our inequality. The other thing that I want to talk about is right here. This sometimes confuses people when they see x divided by 4. Remember, if we put a 1 in front, then really what we see is this is negative 1 divided by negative 4, which is a positive 1/4 x, but 8 divided by negative 4 is negative 2. And so we see that we have this is what's called the boundary line, is we've got a line with a slope of negative 2 and a slope of 1/4. So what I'm going to do is we're going to graph the boundary line. Okay, graph the boundary line. So we are basically thinking about graphing the line y equals 1/4 x minus 2. The only difference is make sure we don't necessarily just make it a solid line. Okay, we need to think about if it's going to be a solid line or a dotted line. So I'm going to go ahead and set up my graph right here. And so it kind of helps space-wise if you go ahead and kind of try to evenly mark off your grid before you get going graphing. All right, so what I have is this boundary line is going to have a y-intercept of negative 2. So right down here, and the slope is 1/4, so up 1 over 4 units. Okay, we could also go down 1 and also go to the left 4 units, and so get at least 3 points on the line. Now, if my inequality, okay, again, this is a less than, so we are going to use a dotted line if we have less than or we have greater than. And so what I'm going to do is I'm going to make a dashed line right here. Okay, and just as a reminder, we're going to use a solid line when I have less than or equal to, greater than or equal to, and of course equal to, which is why we're used to graphing solid lines. So the last thing that we need to do is we need to shade our inequality, okay? And this is usually where I feel like students have the most trouble, is when it comes to the shading. And so here's the way that I think about this, right? Our inequality is y is less than 1/4 x minus 2. And so put your pencil on where the y's are getting smaller and smaller and smaller. And hopefully your pencil is somewhere down here. As your y-axis gets smaller and smaller and smaller, this is where the y-coordinates are less than the line. Well, where are the y-coordinates getting bigger and bigger and bigger? And they're getting bigger and bigger right here. So this is where your y-coordinates are greater than the line. So since our inequality is y is less than, we can see right here, we're going to shade this direction. So we're shading all the values, right, of y that are less than the line. And all these points in the shaded region represent the possible solutions of this inequality. So the next example that I want to look at, okay, so we graph the boundary line, and you know what, if number 3, we have to figure out how to shade. All right, so the next thing that I want to talk about is this question. Is the ordered pair 4-1 a solution? Okay, we can go ahead and answer that question yes or no. But then I'm going to ask you, is the ordered pair -5, -2, -5 a solution? Well, since we already have the inequality graphed, I think we could use our graph to answer that question. So let's find the ordered pair 4-1, and what we find is the ordered pair 4-1 is right here. Now, it is on a dotted line. What that dotted line means is that anything on that boundary line, since it's dotted, is not included. the same way that an open circle on a number line means that it's not included. So the answer here is no, because it's on a dotted line. If that line was a solid line, then the answer would be yes, because that would mean a solid line would mean that the boundary line is included. So next question, is -2, -5 a solution? Well, let's find the point -2, -5. 1, 2, 3, 4, 5. And -2, -5 is right here where that green dot is in the shading. And so the answer to this would be yes, because any point in the shaded region represents a solution. Okay, well, let's go ahead and look at a couple more lines, okay, because this is usually where we sometimes have trouble, is when maybe we see our vertical and our horizontal line. So how would we graph the line x is less than or equal to 4? Well, let's start by go ahead and let's make our graph. Okay, I'm just going to count 5 units in each direction. All right, and then like I always say, if there's any point you need to take more time to set up something, just hit the pause button and resume when you are ready. So we need to graph the boundary line x is equal to 4. Well, I'm going to come over here to the x-axis and I'm going to plot a point at 4. The line x equals 4 is the vertical line that goes through the x-axis at 4. And the reason that I'm using a solid line is because of the extra or equal to. Okay, so now we need to think about our shading. So let's just reason through this. Let's think about this, okay? Put your pencil where the x coordinates are getting bigger and bigger and bigger. Hopefully your pencil is out here. This is where the x coordinates are getting bigger and bigger and bigger. Put your pencil where the x coordinates are getting smaller and smaller and smaller, and that is going to be out here to the left. This is where the x coordinates are getting smaller. So since the inequality says less than or equal to 4, I need to shade all the coordinates that are to the left of the line, because that is the direction where your x's are less than, okay? So it looks like a solid line with everything shaded to the left. Well, let's take a look at something like this. What if we have y is greater than or equal to -3? So again, I'm going to set up my graph. Let's go ahead and just kind of move 5 units in each direction. All right, so the boundary line, again, is thinking about what the line y equals 3 looks like. I'm sorry, y equals -3. Well, y equals -3, we're going to come down to the y-axis, and we're going to put a point at -3. This is going to be the horizontal line that goes through the point. And again, I'm using a solid line because of the extra or equal to. If it just said greater than, I would use a dash line. And so let's think about our shading again. Put your pencil where the y's are getting bigger and bigger and bigger, and I hope your pencil is somewhere up here. So this is where the y's are getting bigger. Put your pencil where the y's are getting smaller, and hopefully your pencil is down here. This is where the y's are getting negative. And so if you think about it that way, this is where the shading above is where the y's are getting greater than, and shading below is where the y's are less than. Since this is greater than or equal to, we are going to shade above this horizontal line. Okay? So that's how I'm going to kind of figure out the shading. If that does not work for you, then we can definitely talk about more strategies in class for how to figure out the shading. So last example, example 4. Is the point 6, 4 a solution of 4x minus 3y is greater than 12? Okay, well, since I don't want to necessarily make a picture, that the best thing to do would be to plug our point into x and y. And so what I can do is I can come into my equation and I can replace the x with the coordinate 6, and I can replace this y with the coordinate 4, and then I can solve this little inequality to figure out if it's true or false. So 24 minus 12 is greater than 12. Let's keep going. 24 minus 12 is 12. So now it comes down to whether or not this is true or false. Is 12 greater than 12? And the answer is no. It's equal to, okay? So this is false. And since it's false, I would say that it is not a solution. And so when you are asked to justify or show work, this right here, your work of plugging it in, is your justification. This is how you show work. Your answer is not a solution. Okay, so just as a final thought, how could I change this inequality to make it true? If I would have said greater than or equal to, now that would be a true statement. Okay, so I just wanted to kind of throw that in there. I'm going to get rid of this and I'm going to leave my answer as being false. I just wanted to kind of show that last thing. So that is it. I hope this was a good refresher and helps you remember how to graph inequalities. See you next time.